All right. Hey, everybody. So we are doing our second office hour today. Before we get into what I want to talk about, which is pickling your model, which I'll explain again in a little bit, question about over and under sampling data. And oh wait, just to clarify, Justin, you are over or under sampling by just taking a random subset of your data frames?
Yeah, correct. I'm just using imbalance, the IMB learn
Oh,
random
okay.
over and under sampler.
Perfect. All right. So first off, make sure when you're over and under sampling, it's only on your train set. And also it is only done after you've done all the other transformations you want to do. So for example, if you're oversampling your data, when it goes into your model, you have, okay, let's just say that this is, yes, this is smoke, but pretty much the same thing. You have your X train and Y train oversampled. When you are dot fitting your model, which is down here, that will be on your oversampled data. That's correct, because if not, yeah, you're fitting your model on your resampled data, whether it's over or undersampled. Now, when you make your predictions, it's still on your original data. So here you can see that I'm dot predicting on just my old X train X test, not my over or undersampled X train, X train, yeah, it's on the original X train and X test data. Does that answer your question? So there wouldn't be anything that, you wouldn't have any predictions that are not, one, you won't have any like fake data. You won't have, and you won't have like, if you have oversampled, you wouldn't have extra of the same data points. And then also if you undersample, you won't be missing out on certain data points as well.
Okay, so you can over and under sample during while you're pruning out the columns before you pass them through the model, or would you wait and run the modeling first, and then prune everything out?
So the model learns different information only based on what you dot fit it. So you could actually try one without any oversampling, dot fit your model in that, get some results. Maybe it's not great. And then try a version with your resampling step. Remember the resampling, whatever kind of resampling you're doing happens right before you fit it. So this is the step that comes right before fit. And before this, I have some other things. So yeah, you can compare those results. So wait, was that your question?
Sort of. Yeah, because what I'm trying to do is what I was doing was running over and under sampling to fix the imbalance before the step of passing it through the modeling. Basically during the rest of the EDA of just making visualizations of what I've got.
Got it. Yeah. So, I mean, for this project, honestly, I'm not going to nitpick on that, but that is potential data leakage. And also your EDA will be on, well, if you're conducting EDA on like your resample data, your EDA will be biased by non-representative set of data.
Okay, so then you should correct the imbalance after you've passed everything through the model, to correct it, and then to correct things and then derive. Okay, got it. All right, I'm looking at it backwards. I'm looking at it backwards again. Okay, all right, thank you. That's all.
Not to worry. Yeah, and also I know we have a one-on-one, I think, tomorrow, so we can talk about it then as well.
Yeah, I think that this actually answered my question, because I was wondering why the numbers made no sense when I was trying to undersample it basically I haven't even gotten to the actual modeling step. I'm still doing the visualizations of what I've got in terms of the data, and I figured I thought about fixing the imbalance there, and I tried it, and I was wondering why some of the data didn't make any sense.
That makes sense. Okay. All right. Awesome. Any other questions on any project thing at this point?
Yeah, so I guess kind of the same topics. We have to worry about imbalance in the feature columns or just in the target column?
Oh, good question. Only in the target column. If there's imbalance in the feature column, you want your model to see that. Just because, yeah, the feature is not the target. Yeah, the problem with class imbalance is if the target class is imbalanced, your model just doesn't have enough information to learn anything about a potential target. So yeah, you only have to worry about class imbalances with respect to your target variable.
Okay, thanks.
You're welcome.
Sorry, is there like a accepted threshold for imbalance, or it just really depends on the data you're looking at?
Good question. Yeah, there is no accepted threshold. It really depends on your data. And I know this is very abstract, but it depends on your separability of your data. The whole thing I was talking about yesterday with respect to, okay, let's use this blank space. It depends on the separability of your data. So if your data is, where is my annotation? So if your data looks something like this, okay, let's just say these ticks are one class and these crosses are another class. This is severe class imbalance, but because in your feature space, it's very separable, your model will actually still be able to work. So whether you incorporate rebalancing in your pre-processing steps, really, I think depends on your initial modeling. Like I would say, try some models without any resampling just to see how it performs. If it's doing well, great. You actually might not have to worry about it. Or maybe you still want to try it just to see if it maybe improves anything or not. But yeah, you might have this kind of scenario if you have class imbalance and you're like, okay, it's obvious that, okay, if a certain feature is way out there, even though we only have such a few instances of this minority class, you can actually still separate them. However, there are situations where, ignore those for now, let's say your data looks like this, and you actually have very, very balanced classes. You actually still will not be able to get good classification results. Also, if you have imbalanced classes like this, remember that smoke actually might not help. But yeah, all of these things you kind of have to think about like semi-independently. Moral of the story, no, there is no threshold. See how your baseline or vanilla models perform first. And typically a sign for whether you use rebalancing techniques is if your confusion matrix looks something like it's all predicting the majority class. Now that's a very clear sign that you should try some sort of rebalancing technique. Any other questions at this point? Awesome. Oh, I just drew an X on. Okay, so today's office hours, I want to talk about pickling a model. Now, something I mentioned right before I started the recording, pickling a model is for productionalization and to use your models outside of your notebooks, like outside of your Jupyter notebook. Because likely if you ever wanted to, use your model in an app or use your model on a website or some sort of web app, you can't run it through your Jupyter notebook. So I'm going to walk through that process. For this project, it's not necessary to pickle your model. However, later on, I'll talk about creating like a prediction function that might be something that you do. Cool. All right, so first, we're going to import all of these things. The only new thing that I'm going to import is Pickle, which is over here. So we're going to import that later. Cool. But all of these are the same. We're going to use this banknote authentication data set, which we talked about with, I think, SVM. So first, just choose what your final model is going to be. This is something that you're going to do probably in the next couple of days, but pick your final model. So in this case, I'm just going to quickly do a pipeline. Oh, and by the way, this works for pipelines too. So any sort of variable or object that you can call like .fit, .predict on, that can be considered a model object, even though it has multiple components. It works on a pipeline. It will also work on a model itself. So let's just fit and predict our model. So let's just say, okay, great. These are my metrics. I'm happy with these metrics. And what you have to do now is, let's say, okay, I really like this random forest standard scalar model. I want to use this for a website where I can make predictions on the authenticity of banknotes. All right, so what you want to do then is pickle your model. I put the code over here so that you can copy and paste the syntax if you like, but you import pickle, and then it's pickle.dump, which is sort of like save. Save the model object, and also make sure that you've already fit your model, because if you pickle and a non-fit model, it will have no information in it. And then open, you give it what you want to name the file, and I'll show you all that here. It creates this model.pickle. And that's literally my model variable saved. So model.pickle is my model. Close this out. And then WB means write bytes, where you're writing the bytes of this model. And so that has essentially saved our model. So if you ever want to save your model for reuse, actually you can even use it in a different notebook. Let's just say you want to have like a clean notebook for like your analysis or something like that, just based on your final model. You can do that with this as well. Cool. So this is how you just save your model. Next, how do you use your model? So first we have to talk about, before getting into like using it somewhere else, how do we make predictions? Now, you can make a prediction function, and if you're going to productionalize your model, you're definitely going to have a prediction function. So the way that model objects work in their .predict is you have to feed it in an array of numbers that match the columns of your training data. So if we take a look at our training data, if we do an xtrain.describe, we only have 4 columns here. So with 4 columns, this is pretty easy. Of course, when you get to more and more columns, if you have like a bunch of dummy variables, your prediction might be a little bit more complicated. But essentially, just to test it out, what you have to do is do a pipeline.predict, or whatever your model is called, .predict, and you just give it 4 numbers. So in this case, I just wanted to inspect like what kind of numbers make sense. When I run .predict, it gives you a prediction. And in this case, 0 is authentic, 1 is forged for banknotes. I had to look this up earlier. Note that this format, and let me zoom in a little bit more, it's double square brackets. The reason for that is it has to take in a 2D array. The .predict just has to take in a 2D array. And this just allows for making multiple predictions. So let's just say I want to also make a prediction on this. It will make 2 predictions. So yeah, that's the syntax for .predict, which is why I have to wrap it in double square brackets, which actually, let's take a quick segue and talk about this real quick. If we do np.array like this, if we do .shape, it's 1, 4, 1 row of 4 numbers, which is different from if we were to do this. This is just 4 numbers. So take note of that. If you have any errors, that's what you have to do. So you want 1 row, 4 values. So that's the reason why you have to do the double square brackets. Cool. Depending on how complicated or how many columns you have, you can create this prediction function. So if you take a look at this, I pretty much only have 4 variables in this data set. I also asked you all for at least 10 in your data set, so it's not going to be this straightforward for you. But in my case, I'm going to feed it in the model object. Variance, skew, kurtosis, and entropy. These are basically the features over here. And I'll just do model.predict these numbers. And if the prediction is 0, authentic, else return forged. So you can see here, this will return a bunch of 0s and 1s. Also, you can see that because it supports getting multiple, I don't know if those numbers will work. Actually, they might. Okay, because it supports taking in multiple lines of data for the .predict. I mean, that's how it works on your test set. You have to pick out the first one if you're just looking at 1. So here, that's why I have to do predict 0, because if I do this, you can see that is an array, but if I do 0, it'll be either 0 or 1. That's how you get the integer value out. So if it's 0, return authentic, else return forged. Cool. So let's test this out. If I do make prediction and I'm feeding it my pipeline, and let's just say I want to test for all 0 values, it'll return forged. If I want to change it a little bit, I don't know what these values are supposed to do. Cool. This one is authentic. So just like that, we've been able to use our model on previously unseen data, or like completely raw data that maybe like you have a website where people can like upload their like numbers. And by the way, creating a website where you can do this, I'll talk about this when we get to capstones. But this is the first step to getting there. Any questions about this prediction function? Cool. If you have like a lot of dummy variables, I know like the one hot encoder, actually, if you do like a dot transform, you could input just random data and have it output the array that you want. But yeah, it really depends on what kind of pre-processing steps you have. If you like standard scale, if you standard scale your data outside of the a pipeline, you would have to include that step in here as well. So yeah, make sure you're doing all the right pre-processing steps that you need. Cool. All right. Next step is to put it in a script. So first of all, this is how you open a pickle object. So just to demonstrate how this works, I'm just creating a new variable, and currently the variable model doesn't exist, just to show that it's not saved already. So I'm going to create this new variable model, and I'm going to load up my model pickle file. Remember, model comes from here. I'm going to open the file, and RB stands for read bytes. So actually, let me just put that comment here. Read bytes. And when I do this, great, no errors, and I can make my predictions. This is forged. If I change it to ones over here, based on what that is, it should be authentic. So just like that, we have repurposed our model. If I copy and paste this code into another notebook, it will work fine as well. Next, we can also put this in a script. I talked very briefly about scripting last time, and I see that a few of you have started to employ a script, which is awesome. But if you want to do this, all I'm doing here is I'm importing all of my libraries. I think I might not even need to use pipeline, to be honest. I actually don't think I need to use these either, but just to be safe, I'm copying over that make prediction function. The one difference is I am opening my model there. You can actually probably also open your model outside of the function, but not a big difference. It really depends on how you want to use it, and you'll be able to make these decisions better when you get to your capstone project, hopefully. But here I have my make prediction function. Now, I do want to show you all something really cool. And let me just reshare my screen so you could see my, so that you can see my terminal. So let me reshare my screen real quick. Where's the reshare button? Oh, there we go. Okay, so I have my terminal over here. And why am I drawing? Okay, let me make this a little bigger. Cool. So this is the directory that contains my banknote prediction function. So one way to test to see if this script works is you can actually run Python through your terminal, which is something I don't think I've ever talked about. Might be slightly different in Git Bash if you're on a Windows computer. So look it up, or let me know. I'll look it up for you, I guess. But to run Python, I'm running Python 3, and I do Python 3 banknote _pred.py because that's the name of my file. Oh, sorry, not this. Banknote 3, Python 3-i, because you want to interact with your Python kernel, and I'll show you why later. Banknote pred.py. When I run that, what this has done, it's actually executing all of these lines. So my model, this function's already existing. It's also imported all of those libraries. So this over here is actually a Python kernel. I think it's a Python. Yeah, I forget what the term for it is, but you can do Python in here. So if I do like 1 + 1, I can do all sorts of Python things here, but it does execute line by line. I can even do like for I in 1, 2, 3. I think if I do, yeah, print I, print that. So just in case if you needed to really quickly do Python, I actually use this as a calculator sometimes myself. So just something that's good to know. But anyways, this kernel has already run my Python file. So because of that, I can actually already make predictions. So if I do make prediction, and it also does tab autocomplete, which is neat. And let's say I want to give it 0, 0, 0, and 0. It will tell me that it's forged. If I want to do the same thing, but let's say I want to change my numbers up, I guess this one's also forged, and I can keep testing it over here. So as long as this works, it's pretty safe that if you ever were to take this function and put it like on a website or in an app or something, it will also work. And the problem won't be with your Python script. So yeah, this is something that I thought would be good for some of you to know, especially those of you who are more comfortable with writing functions. Of course, I'm going to go over all of this again when we get to capstones, because I do think it'll be really cool if you all had, like at least some sort of front ends for all of your final projects. But for now, for those of you who have the extra capacity to do something like this, or even if you just wanted to make predictions, I think even going back to look at creating a function like this for your data, I think that'll be useful as well. But yeah, any questions on this? Awesome. Well, this was the main thing that I wanted to share. Does anyone have any other questions regarding the project at all? I know we still have like 35 more minutes. If there are no questions, y'all can just keep at it, and happy to take one-on-ones, answer questions on Slack as well. Awesome. Very cool. Well, tomorrow's office hours, I don't have anything specific to talk about. Send me questions if you have any. If not, I might actually cancel office hours. So let me know if you have questions or of anything about anything regarding your project, because your presentation is on Friday in 2 days. So yeah, please send your questions over. If I get enough questions, I will still hold office hours. But if not, I feel like all of you are fairly independent, working on your own, and I've gotten a bunch of really good questions over the past couple of days. So yeah, we might not need the office hours tomorrow. Any thoughts on that? Cool. Well, if there's nothing else, keep your questions coming to me on Slack. Let me know if you need anything, and yeah, I'll maybe see y'all tomorrow, if not on Friday. Cool. Have a good rest of your day, everybody.